Wonderful day, everyone! Okay, last time we had discussed factoring polynomials using greatest common monomial factors and also the difference of two squares. Now, I'm going to discuss another factoring technique of factoring polynomials, specifically the sum and difference of two cubes. But first, what do you mean by cubes or perfect cubes? Okay, last time we had discussed or reviewed about perfect squares. Perfect squares is any number that can be expressed to the power of 2. How about perfect cubes? So, the same with perfect squares, perfect cubes also, we need to express this to the power of 3. So, perfect squares, power of 2, here to the power of 3. Okay, example, 8. 8, that is 2 times 2 times 2. So, if we're going to express this to the power of 2, to the power of 3, this becomes 2 cubed. Okay, so meaning 8 is an example of a perfect cube number. Okay, how about this? X cubed. So that is x times x times x. So very clear that x cubed, this 3x, we're going to express this into the power of 3, that is just x cubed. So, very clear that x cubed is a perfect cube. Now, since we're going to factor sum and difference of two cubes, let's have sum first. What do you think will be the factor of x cubed plus 8? Let's have sum. But let's recall first the topic in grade 7, special product. Okay, you have here a plus b multiplied by a squared minus ab plus b squared. Okay, their product is just a cubed plus b cubed. So, we have here binomial and a trinomial. Their product is the sum of two cubes. So, meaning, if we're going to factor this a cubed plus b cubed, this results to the quantity of a plus b times the quantity of a squared minus ab plus b squared. So just the reverse. So, if we're going to use the pattern, okay, let's use the pattern. A cubed plus b cubed their product is just the a plus b times the quantity of a squared minus ab plus b squared. So, that's the pattern class. So, we're going to get this a. Okay. So, again, when you say perfect cube, a perfect cube is a number that can be expressed to the power of 2. To the power of 3. So, the number that is expressed to the power of 3, so you have there the base is a. Or, in short, it's the cube root. Okay? Cube root. Okay. Cube root of a cube is just a. So that is the reason for a. Or if you find it hard, just take away the base. Okay? And then you have here the b. And then take the square of this a, the first term of the binomial factor. And then you multiply the two terms. Then subtraction. Multiply a times b, that's ab. And then square b. Or square the second term of the binomial factor. Okay, let's take a look. Okay. You have here x cubed plus 8. Okay, we're going to express each expression first to the power of 3. X cubed plus 2 cubed. Okay, you do the pattern. Okay, the base for the first term. So that is x. The base for the second term, that is 2. Okay. From your binomial factor, you get your trinomial factor. So you just square the x. So that's the first term. And then minus. Then multiply the 2. X times 2. That is 2x. And then square the second term of your binomial factor. That is 2 squared. So, the answer is, or the factors for x cubed plus 8 is the sum of x plus 2 multiplied with the product of x squared minus 2x. 2 squared is 4. Okay. That's it for the sum of two cubes. Now, how about the difference of two cubes? Let's have that. So, for a cube minus b cube, this is the pattern. You have here the difference of a minus b. So, you just take the base for the first term, a, and then take the base for the second term, b. And then take the square of the first term of your binomial factor. So, a squared. And then plus. And then you multiply the two terms. A times b, that is ab. And then square the second term of your binomial factor. That is b squared. Okay, that is the pattern. Now, let's try x cubed minus 8. Okay, again, express each term into or to the power of 3. So you have your x cubed minus 8 is 2 cubed. Okay. The next, you take the base for each term. So for the binomial factor, so you have their x, the minus the base of 2 cubed, that is 2. And then from your binomial factor, you get your trinomial factor. So square the first term of the binomial factor. So x squared. And then plus. Then multiply the two terms. 2 times x, or x times 2, that is just 2x. And then square the second term of your binomial factor, which is 2. So that is 2 squared. Okay, simplify. So you have your x minus 2 times x squared plus 2x, and then square of 2, that is 4. Okay. Okay. A while ago, let's take the difference. So from above example, x cubed plus 8, the factors are x plus 2 and then x squared multiplied by the quantity of x squared minus 2x plus 4. Okay. Take a look their difference. So here, as you can see, they differ only in signs. So that's the pattern. For the sum, a cubed plus b cubed, that is the sum of a and b, and then times the quantity of a squared minus ab plus b squared. Okay, so they differ on the sign of your binomial factor, and then the second term also of the trinomial factor. Okay? Now, let's have examples. Example. Okay, factor the following. Okay, let's have example number 1. Y cubed minus 27. Okay? So the first step is to express each term to the power of 3. So you have your y cubed minus 3 cubed. And then you get the factors. So you have your, take the base of y cubed, that is y. Take the base of 3 cubed, that is 3. And then from your binomial factor, you get the trinomial factor. So square the first, it's y squared, and then plus. You multiply the two terms, y and 3, that is 3y. And then you square the 3. 3 square. Okay, so for final factors, you simplify the difference of y and 3 times the quantity of y squared plus 3y, and then you get the square of 3, that is 9. Okay, that's our first example. I'll give you another example. Okay. 8x cubed minus 64. Okay. So the first step, you express each term to the power of 3. So you have 2x quantities cube. Okay. Minus 64 is 4 cube. Okay. Okay, next. Okay, you take first the binomial factor. Same thing, you take the base. That's 2x. The base here, minus 4. And then, from your binomial factor, you get your trinomial factor. So, square of the first, that is 2x. You square it. And then you multiply plus. You multiply the two terms. So 2x times 4. And then you square the second term, which is 4. So 4 squared. Okay. And then you simplify. So you have 2x minus 4 times the quantity of what is the square of 2x? That is 4x squared. Then multiply 2x and 4. That is 8x. Plus square of 4. That is 16. So the factors of 8x cubed minus 64 are 2x minus 4 and the trinomial 4x squared plus 8x plus 16. Okay. Now, I'm going to give you another example, number 3. Okay, let's have another example. (27m to the power of 4 minus 8m n to the power of 6. Okay. Again, you express each term to the power of 3. Okay, but notice, okay, this is 4. But notice, I'm going to erase. This is to the power of 4. Okay, but notice when 7m to the power of 4 cannot be expressed to the power of 3 because of this m to the power of 4. The same here, 8m n to the power of 6. M is not a perfect cube. So, what are we going to do? Okay, go back to our lesson, factoring using the GM, greatest common monomial factor, or GCMF. So, you look for their GCMF first. Okay? So, their GCMF is, okay, as you observe, their common factor, or GCMF, is just M. Okay, so then, to get the other factor, you divide each term by the GCMF, which is M, minus 8m n to the power of 6 divided by m. Okay. So you have m. Okay, so you have your 27. Because m to the power of 4 divided by m, that is m cubed. Just subtract the exponent 4 and m, you have an exponent 1. So 4 minus 1, 3. So, and then 8 m n to the power of 6 divided by m is just 8. And you have m divided m, that's actually 1. So 8 times 1 is that is just 8. And you have your n to the power of 6. Okay, next. Okay. And then you factor 27 m cubed minus 8n to the power of 6. They are both perfect squares, the two terms. So you express each to the power of 3. So you have m times, say 27m cubed is just 3m to the power of 3. So, the cube of 3m. Minus 8 is 2. Then n to the power of 6, that would be n to the power of 3. That is n squared to the power of 3. So, if we're going to check, 2 times 3 is 6. Okay. Next. So, copy some m. You take the binomial factor. So, the 3m minus the base for the second term. That's 2n squared. And then, you take the trinomial factor. square of 3m plus, you multiply the two terms, 3m times 2n, and then you square 2n square. Okay, so simplify m times 3m minus 2n squared. Okay, square of 3m, that is 9m squared. You multiply 3m times 2n, that is 6mn, plus square of 2n squared, that is 4n to the power of 4. Okay, so they are the factors of the difference of 27 m to the power of 4 minus 8m n to the power of 6. Okay, so as you can see, our examples are difference of two cubes. Now, I'm going to give you another example on sum of two cubes. Okay, let's have fourth example. 1 plus 8k cubed. So again, you get the you express each term to the power of 3. So you have your 1 cube plus express 8k cubed to the power of 3. That would be the quantity of 2k cubed. And then, you take the bases of each term. So the base of 1 cube is just 1. Plus the base of this second term, that is 2k. And then you get the trinomial factor. Square of the first, which is 1. Then minus, you multiply the two terms, 1 times 2k. And then square the second term, 2k. Okay, simplify. So the sum of 1 and 2k multiplied by 1 square is just 1 minus 1 times 2k, that is 2k. Square of 2k, that is 4k squared. Let's have fifth example. So you have here 5h plus 40h k cubed. Okay, let's check first if the two terms are perfect cubes. So, since there are two terms, so it could be sum of two cubes. But check if they are perfect cube. So 5h, that is not a perfect cube. 40h is not also perfect cube. So it might be there is GCMF, or greatest common monomial factor among the two terms. So what would be the GCMF? So the GCMF is 5h. Okay, you factor 5h for the two terms. So you divide each term, 5h divided by 5h plus 40h k cubed divided by 5h. Okay. Okay, so you have 5h. 5h divided by 5h, that is 1. Plus 40 divided by 5, that is 8. H divided by 8, that's 1 also. 8 times 1, that's 8. And then k cubed. Okay. Previously, we had already discussed the factor of 1 plus 8k cubed. Factor for 1 plus 8k cubed from our example number 4 are the sum of 1 and 2k, and then 1 plus 2k plus 4k squared. Okay. That's all for sum and difference of two cubes. Stay tuned for another lesson on factoring techniques. God bless.